All right, good afternoon. This is Schweitzer. We're going to look at a couple of things here involving mass and stoichiometry. A few things we just want to make sure we understand is that anytime on a human level that we're trying to measure something that is extremely tiny, right? And there's lots of them. What people do to make this work, because it's not practical to count individuals that small, we simply throw them on a scale and we weigh them. So in this situation, we just still need, if we have the mass, a way to relate sort of like the mass ratio to the actual number of particles. So with that being said, we need some number to mass ratio. So in this situation, a couple of things you might also want to realize is that as far as mass is concerned, a chemical reaction, like let's say NaCl, goes to Na plus Cl2, so we need a 2 here and a 2 here, that these numbers here, let's back that up a second here, it would be Na plus Cl2, so we'd need to have a 2 here, yep, so we'd have a 2 here and a 2 here. Sorry about that. Okay, 2 Nas, 2 Cls, 2 Nas, 2 Cls. So these numbers right here and right here and right here represent the number of particles. So when you talk about that in that terms, you should note that in this situation, this weighs 50 grams. So over here, we should have 50 grams. But does that mean that, well, there's 2 of these and 1 of these, there should be twice as much mass here and half as much mass here? And the answer is no. So the actual mass is determined by the number of protons inside and neutrons inside the actual atoms of those guys. So there's a certain percentage of mass that's in here and a certain percentage of mass that's in the chlorine. And that same percentage should add up right here, and the same percentage should add up right here. It's not half and half. So mass really has almost no advantages. It is useless, except for this factor right here, which allows us to weigh things and count. So mass simply is a means to count, and that is really important to understand that, and then we can work with it. So let's try this problem out. Calculate the mass of each product. How does that work? Well, I'm going to get myself a clean formula here. 2 NaCl's goes to 2 Nas plus 1 Cl2. Initial stoichiometric ratio. And now again here, the main thing here is that you got to realize that this table is working with numbers of particles in this ratio. I cannot put grams in here. That's the biggest error right there. So I'm going to go with my 50 grams and get rid of the grams and go to the moles. 1 mole for NaCl. Alright, so NaCl, this is 23, this is 35.4, and let's just make sure we got that. 35.4, and the 23 is good. Alright, that's going to give me 58.4 grams per mole. 58, so I have less than 1 mole. You divide that out. 58.4, we'll make sure we get the full sig figs here, not cut ourselves short. 50 divided by 58.4 is 0.856. So this is 0.856 moles. So minus 0.0, so I should say minus 0.856 minus 0.856 to 0. That's my limiting reactant, by the way. All right, 2 to 1 ratio. I'm going to gain 0.856, and then here at a 2 to 1 ratio, do that, 0.856 at a 2 to 1 ratio. Half of that divided by 2 is 0.428. 0.428 plus 0.428, 0.428, and this is going to be 0.856, and then there's none of that left. So all my 50 grams is now over here. Some of it's here, some of it's here. Okay, let's take a moment and just convert those back to grams. So let's do that. Let's do the Na first. 0.856 moles. Get rid of moles and go to grams. 1 mole is 23 grams. The chlorine is 0.428 moles. And 1 mole is equal to, now I need to get that, so chlorine 2, that would be 35.4 times 2 is 70.8. 70.8 equals, let's do the math here. So let's do the bottom one first, times 70.8 is 30.3 grams. Okay, so that's 30.3 grams. And this guy is 0.856 times 23 is about 19.6. Okay, which is about 19.6 grams of sodium of chlorine. Alright, so in this situation, what does that mean? Okay, well that's my answer to the question, by the way. But again, that means that inside of my sample size of 50 grams, that fraction of it is nitrogen, that fraction of it is chlorine. We would have seen the same percentage happen if we had done a percent by mass. Percent by mass, we typically use 1 mole. Sample size does not matter. So NaCl, this is 23, this is 34, total mass 58. So the ratio of 23 to 58, that's the mass of sodium, is total times 100 equals the same thing as this. 19.6 of the sodium divided by the total, which is 50, times 100, and you get the same ratio. It's the same atoms, same substance. Alright, so, good stuff there. 25 grams of H2 reacts with 25 grams of O2 to produce water. Who's the limiting reactant? How much water is produced? How is mass different than moles and particles? Again, we just talked about that. Take a moment, pause the video, and give it a whirl. Okay, so we have H2 plus O2 yields H2O. We'll balance it. You need a 2 here and a 2 here. Who's the limiting reactant? I should probably move that whole thing over here. Alright, we'll do it here. H2 plus O2 yields 2H2. I like to leave a little room here just for my ice table. I didn't leave that room there. So who's limiting? Well, let's convert these guys over to moles first. Remember, can't put grams in. So we got 25 grams. Get rid of grams and go to moles. Let's do the hydrogen here. That's 1 mole is 2 grams. That's 12.5 moles. And for the O2, it is going to be grams to moles. 25. 1 is 32, so I have less than 1 mole. Alright, so many people could probably estimate who is limiting just by looking at those masses divided by 32. I have 0.78, so 0.78 moles. So this is going to be here 12.5 and 0.78. And now we want to play our game. Who is limiting? The O2 is limiting. Hands down, we got way less of it. Even though this is being used up twice as fast, you should easily be able to see. Minus 0.78 is 0. Okay, how much water is produced? Now I'm just going to jump right to the answer. I don't want to know everything else. I'm going to go from here to here. So 0.78. Get rid of the O2 and go to the H2O at a 1 to 2 ratio. And I'm going to go right to mass. We'll change that to mass here. 1 mole is 18 grams. So 0.78 times 2 times 18 is 28.1 grams. Alright, so we have 28.1 grams of water. So in this case here, you might say, okay, well, why don't we get 50? And I think sometimes that's really kind of hard for people to understand. Why don't we get 50? Well, think about that for a second. What do you think? And the answer is because we still have some of this left over. So you could say, how much actual mass is left over? Well, this went to 0. We had 50 total. Now we got 28 grams over here. How much is left? So what is that? Minus 50 is 21.8 grams. So if you were to solve this guy out into moles and then convert those moles over to grams, you get about 21.8 grams. All right, 21.8 grams. That would be how much is left to get to 50. All right, another problem here. Okay, go ahead, give this one a try. Only difference here is we're going to first go to liters, and we'll do it at STP. All right, pause your video out for a second and try it out. Small change there. All right, hopefully you tried it out. First things first, as everything, convert to moles. Get our molar masses. This is going to be 1224 plus 6 is 30 grams per mole. This guy is 32 grams per mole. And I got more of this one, but I got a faster rate used. Let's get this guy to moles so I can see what I got here. 12.5 grams. Get rid of grams and go to moles. 1 mole is 30. Okay, now I got similar molar masses, so I'm going to have proportional here as well, but you'll see that in a moment. 12.5 divided by 30. 12.5 divided by 30 is 0.416. 0.416 moles. That's of this guy. I can go ahead and put this in. I'm going to bring this proportional right here. 0.416. Okay, well, the oxygen, we got 38.9 grams to moles. 1 mole is 32. 38.9. 38.9 divided by 32 is 1.21 moles. 1.21 moles. 1.21 moles. I had none of these, and I have none of that. Okay, who's limiting? I have about 3 times as much. 12, 24, 36. Yeah, that's mass is real close because the more mass is named. About 3 times more. But this is usually way faster, I think. So I'm going to run this guy out. Minus 1.21 to 0. Now, before I'm going to jump to that guy, I'm going to jump here just to make sure that my mental math was right. So let's do that. 1.21. Get rid of the 1.21, and actually, hold on a second here. We're going to jump. So we're going to use a stoich ratio, 1.21 at a 7 to 2 ratio. At a 7, so O2 to C2H6, a 7 to 2 ratio. 1.21 times 2 divided by 7 times 2 divided by 7 is 0.34. Okay, it's closer than I thought. 0.34 moles minus 0.34. And how much is left? Now, you don't need this per se to answer the question, but it will be a positive value. And go ahead and subtract. I'm going to save time and just jump from my limiting over to here and convert to liters. So I have 1.21 moles at a 7 to 4 ratio. 1 mole is equal to 22.4 liters because I'm an STP. Okay, and away we go. 1.21 times 4 divided by 7 times 22.4 equals 14.5 equals 14.5 liters. Less than 1 mole, by the way. 1 mole is 22. We have less than 1 mole. And let's move along. Okay. All right. Getting close to the end here. Okay. Take a moment, pause the video, give this one a try. All right, what are some misconceptions here? One is that, okay, that you can't use the grams, right? People say, oh, this is my limiting reactant. Equal amounts, twice as fast, limiting reactant. That is the problem. Okay, so before we get started here, let's flip everything to moles. All right, so we have 50 grams of sodium, and that's grams to moles. 1 mole is 23. 50 grams to moles. 1 mole is 70.4. Now again, here someone might say we have equal grams, way larger molar mass. That means this number is going to be way smaller, which means this might be my limiting. But let's just keep going here. 50.23, 50 divided by equals 22.17. 2.17. And then the 50.74, 50 divided by 70.4 is 0.71. Okay, 0.71. So, oof, right there. Pen got a hold of me. 0.71. So now we have 2.17 and we have 0.71. This is used up twice as fast, but I have more than twice of it. So minus 0.71, 0. You could jump to here if you'd like. It would be a minus 1.4, so there would definitely be a positive amount left. But I'm going to jump from here to here. And it'll be out here. Same math. I just showed that here, just did that in my head, but 0.71 at a 1 to 2 ratio is 1.42 plus 1.42. And we could easily leave that in moles, or we could flip it to grams. It's 58 grams per mole, and I will let you try that on your own if you'd like. We will stop here at this moment, move to your workbook for proficiency, and try this out. Thank you very much.